Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we'll learn how to graph y equals sine x and y equals cos x. So let's start by graphing y equals sine x. So to do that, we're going to need the help of our unit circle that we went through in a previous lesson. So remember, in the unit circle, the sine of theta, the sine of the angle, was whatever the y-coordinate is. So at 0 degrees, the y-coordinate at this point here is 0. So sine of 0 equals 0. So it will go through this point here. Y equals sine x goes through the origin. So at 90 degrees, the y-coordinate here is 1. So sine of 90 is equal to 1. So we can plot that point here. So sine of 180, the y-coordinate at this point is again 0. Sine of 180 is 0, so it will go through this point here. And then similarly, sine of 270 is minus 1, and sine of 360 is the same as sine of 0, which is 1. So what the sine function does, it starts at the origin, it goes up to 90 degrees where it reaches its maximum, then it comes down through 180, minimum at 270, and it goes up through 360. Now, because remember we said that theta and theta plus 360 are the same angle, so sine of 0 is the same as sine of 360. Sine of 90 would be the same as sine of 450. The graph would just keep going forever like this. It would just go up and down like this. It would also do that over here. So sine of minus 90, if you add 360 to minus 90, you get 270. So sine of minus 90 will be down here at minus 1. So this is a continuous function. You can substitute in any value of x. This is what y equals sine x looks like. So there'll be other points on this graph. Of course, we know that for sine of 30 degrees equals a half. So then this point here will be like 30 degrees and a half. So just be aware that I've graphed a sine equals x in degrees because the x was in degrees. If you wanted to graph it in radians, the graph would look the exact same. It's just, we'd have a different scale on the x-axis. So this would be pi on 6, pi on 2, pi, and so on all the way up to 2 pi. So that is the graph of y equals sine x. So now let's graph y equals cos of x. So cos of x, remember in the unit circle, the cos of theta was just the x-coordinate, so cos of 0 is equal to 1, because the x-coordinate at this point is 1. So unlike sine, cos actually starts at 1. Cos of 90 is 0, and using the unit circle, we get cos of 180 is minus 1, cos of 270 is 0, and cos of 360 is also 1. So, joining up all those points for y equals cos x, we get something that resembles a parabola. Of course, it's not a proper parabola because, like the sine function, it keeps going. So it would go up and then it'd come down again and go up and so on. So, both of these keep going. They're like waves that keep going. So y equals cos x is the red graph, y equals sine x is the blue graph. So they are similar, it's just actually like the blue graph is just the red one shifted over. Cos starts at 1, sine starts at 0, and we're going to be looking at applying transformations to these graphs. Alright, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.